The integration of LangChain with Typesense allows users to refine search queries using metadata, enhancing search result relevance. This functionality becomes crucial in scenarios requiring precise data retrieval based on specific criteria, such as document type or creation date. Now, let's delve into vector stores and Typesense. Vector stores are databases that store vector embeddings, numerical representations of data, enabling similarity searches. Typesense is a search engine specifically optimized for speed and relevance, making it well-suited for vector search applications. Now, consider the LangChain ecosystem. LangChain is designed to simplify the creation and management of LLM applications by providing modular components. Now, let's examine similarity search capabilities. This involves using vector embeddings to find data points that are similar to a given query. Typesense's architecture is crafted to perform these searches efficiently. Now, let's consider metadata filtering. It allows searches to be refined based on associated metadata, improving the relevance of the results. Let's break down the quiz question. It presents a scenario involving the langchain_community package and its interaction with a specific kind of database called a vector store, particularly Typesense. The question asks to identify which of the given statements accurately describe this integration. Statement A focuses on similarity searches. A key aspect of vector stores is its ability to find similar data points quickly, using vector search capabilities. The statement suggests the integration effectively uses Typesense's own built-in feature for this purpose. Statement B talks about automatic chunking and indexing. Chunking is the process of breaking down large pieces of text into smaller, manageable segments. Indexing is how the data is organized for faster retrieval. The statement questions if the integration handles both automatically. Statement C brings up the concept of in-memory loading. It posits that all data must be loaded into memory before the indexing process can begin. That is, every document should be loaded before indexing. Statement D introduces metadata filtering. Metadata is additional information about the data, like the author, date, or category. Filtering means narrowing down search results based on this metadata. Now, let's zoom in on similarity search. This refers to the capability of a vector database, like Typesense, to find data points that are similar to a given query. Metadata filtering is important. This allows searches to be refined based on the metadata associated with each data point, such as author, date, or category. The correct answer combines options A and D. This indicates that the integration likely supports efficient similarity searches and metadata filtering. Greetings. This line names the specific integration that is the focus of this quiz. A vector store is a database designed to store vector embeddings and perform similarity searches. langchain_community provides integrations for interacting with various vector databases, and this problem specifically addresses the integration with Typesense, a search engine that supports vector search. Okay, this is the actual question being asked. It asks to identify the true statements about how langchain_community integrates with Typesense as a vector store. Wonderful. Option A focuses on similarity searches. Remember, vector databases are designed for this very purpose. Typesense has built-in features to allow efficient similarity searches. The question is whether the langchain_community integration exposes and utilizes this functionality. Alright. Option B is about automatic chunking and indexing. LangChain supports chunking, which is the process of breaking down larger pieces of text into smaller, more manageable segments. But it's important to understand which part of the LangChain ecosystem is responsible for chunking versus indexing when integrating with Typesense. Sounds good. Option C relates to in-memory loading. Most efficient vector databases are designed to handle large amounts of data without requiring everything to be loaded into memory. The problem hints whether the statement is aligned with efficient vector database design principles. Cool. Option D refers to metadata filtering. Metadata filtering allows one to narrow search results based on specific attributes associated with the data. The question is if this integration takes advantage of Typesense's capability to filter based on metadata. Awesome. A and D are the true options. Okay, an explanation of the answer. Now, let's delve into what the integration is mainly about. It's about making these two systems, langchain_community and Typesense, work together effectively. It helps in using Typesense as a place to store and search through vector embeddings. Yay! Let's discuss similarity search. This is super important because it's how the system finds the most relevant results based on how similar the vectors are. Typesense is designed for this, so it can quickly find the closest matches to a query. Let's talk about how data is prepared and stored. While LangChain can handle chunking, which is splitting text into smaller pieces, this specific integration focuses more on indexing the data after it has been chunked. So, it's less about automatic chunking within the vector store itself. Let's explore the filtering of search results using metadata. This means filtering search results based on categories like author, date, or any other relevant information stored with the documents in Typesense. This integration allows filtering capabilities. Let's consider whether the entire dataset needs to be loaded into memory before indexing. This is about whether the system can handle large datasets without needing to load everything into memory at once. Efficient systems usually process data in smaller parts to avoid memory issues.